Okay, so here we have a waste paper trash can that is in shape of a cylinder. And notice that it says it's open, so that means there's no base on the top. There's just a base on the bottom. And so the first question, A, is they ask for the area of the waste paper bin. And so I'm just going to write it over here. So area is equal to the area of the base is equal to pi r squared because it is a circle. And so it's going to be pi times 25 because r is 5. And do not use 3.14, use the pi key. So I put in pi and I got 78.5, and then my is going to be cm squared. Okay, now please keep in mind that that's the answer that I'm writing down. The real answer I got is 78.5398. I would go out to about 4 decimal places. Okay, now they want us to find the height. So let me use another color here. Let me use this brown color. And so we know that volume is equal to the big B times the height. So in this case, volume is equal to pi r squared times the height. And so they tell us that volume is 8,000. We know that the area of the base is, I'm going to use the number that I got, not the number that I wrote down, 0.5398, and times height. So I divide both sides by 78 point whatever, okay? And so I'm going to put 8,000 divided by the answer. And so I get height is equal to 101.859. 859. So my answer is going to be 102 centimeters. Okay, now they ask for the total surface area of the waste paper bin. All right, so what I'm going to do is I'm going to erase what's here. Now, so do you see we have the side, all right, and we have the base. Okay, so let me just use another color here. I'll use a purple. Okay, so we have the total surface area is equal to the lateral side plus the base. Now the lateral side, if you open it up, and I believe the formula is in your formula chart, I just don't happen to have one in front of me. The width of it, it's going to be a rectangle. If you imagine if you ever taken a label off of a soup can, it's a rectangle. And so the length of it is going to be the circumference of a circle, which is 2 pi r, plus the base, which is pi r squared. All right, and so we have 2 times pi times 5, plus we already got the base. And that base is going to be 78. Oh, wait, well, let me just write down, let me just do the math from scratch. It's going to be 25 pi. So I get 10 pi plus 25 pi, which is 35 pi. So I'm going to go to my calculator and I'm going to go find out what 35 pi is, and I get 109, let me write it here, 109.9557. Okay, so if I go to 3 sig figs, it's going to be not 109, but it's going to be 110. And remember, it's still area, so it's cm squared. Okay, so now they ask if her deal is practical. All right, and do you see what we really have here is not the waste paper basket that you typically can think of, but it's going to be long and tall and skinny, right? Because if the bottom is only 5, and the top and the height, what was it, like 102, it's going to be tall and skinny. And really, most of the objects that we throw away aren't going to be, have a, the diameter is going to be 10, right? And so 10 centimeters is really not all that practical. So to say no, since it's going to be tall with a small base. All right. Okay, so let's go over here. This is a part 2 of that problem. And so we have another trash can that also have a volume of 8,000. But this time she decides to fix the radius of the base so that the external surface area is minimized. Okay, so when now you see the word minimize, you think, okay, somewhere in here we're going to do some calculus. So they want us, so C says write down in equations in terms of H and R using the volume of the vent. So what did I tell you? That the volume is the area of the base times the height. Since the base is a circle, it's going to be pi r squared times height. And so we wrote it down here using H's and R's. So it's going to be pi r squared times height. Now, D is show that the total external surface area A of the bin is, what the heck symbol is that? Pi is probably pi r squared plus 1600. Okay, so remember what did I tell you the surface area is? It's the lateral area plus the area of the base. So it's going to be 2 pi r, because that's the length, times the height, plus pi r squared. Okay, and so notice what letter is not in here. Do you see how H is not in this equation at all? So that means I need to come back over here and to solve for H. And so I know that my volume is 8,000 pi r square H. Oop is equal to. So if I want to get H by itself, I divide both sides by pi r squared. So I get H is equal to 8,000 divided by pi r squared. Okay, so now I'm going to come back over here and I'm going to fill that in. So I get 2 pi r, and then it's for H. I'm going to get 8,000 divided by pi r squared plus pi r squared. Okay, so look what happens here. The 2 times the 8,000 gives me 16,000. The pi and this pi cancel out, and this r and one of the r's cancel out, so I'm going to get r plus, and then I get pi r squared. All right, so that is D. Okay, now what they want us to do is to take the derivative of the base based on r. So what I'm going to do, I'm going to write this equation over to the next page. Okay, now I hope you realize that if you weren't able to do D, that is just 2 marks. Just go down and start E. Or remember, for a paper 2, all you have to do is write some answer as long as it's reasonable and then go with it. All right, so before I can do the derivative here, I need to bring everybody upstairs. So this is going to be 1600 r to the minus 1 plus pi r squared. So now I'm going to take the derivative of A, and so I'm going to get negative 1 times 1600 to the r to the minus 2, because it's a minus 1, plus 2 pi r. So pi is a constant. All right, and so now what I want to do is I need to bring it downstairs, so I get negative 1600 over r squared plus 2 pi r. Okay, write down the value, so that is E. Now F says find the value of r which minimizes the total external surface area here. All right, so I need to go to another color because I'm running out of space here. All right, so if I want to minimize, remember I need to find a stationary point. In order to find a stationary point, the slope of all stationary points, the slope of the tangent line is 0, so I need to set this equal to 0. So I'm going to get 0 is equal to negative 1600 over r plus 2 pi r. I'm going to add 1600 over r to both sides. And I get 1600 over r is equal to 2 pi r. Now I'm going to put that over 1. And now I have cross multiplication. So I have 1600 is equal to 2 pi r squared. Divide both sides by 2. And I get 8. It should be 8,000. Shouldn't it be, Schwartz? I've been short a 0 here. Pi r squared, divide both sides by pi. Now, again, I'm going to go into my calculator, 1, 2, 3, and I'm going to divide by the pi key, not that 3.14 business, and I get 2546. So I get 2546.48 is equal to r squared. Take the square root of that guy, and I get 50.46. So I get r is equal to 50.46. And so we need to write it to 3 significant figures. So I get 50.5. So I get h is equal to 50.5. And what are my units? I think they're centimeters, okay? Now, they want to know, is this an improvement? Oh, wait a minute. That is my R, isn't it? I found what R is. So now they want us find the value of R. I'm sorry. R is equal to 50.5 cms. Let me erase this. Now it says calculate the value of H. Okay, so I need to erase this over here. I apologize. And I'm going to change my colors because I think it gets so lost in here with all these different deals. And I'm going to go to a blue. All right, and so what did I get for H? So I'm going to have to think about this for a second. Okay, so I had to write down what the area of the volume was. And so I have H is equal to 8,000 divided by pi r squared. So H is equal to 8,000 and then divided by pi. And I know what r squared is, right? Is this guy right here. So this 2546.48. Okay. So I have that 25.468. So wait, so what I'm going to do, yeah, so 2546.4790, which is what that is. And I'm going to times that by pi. Now that's my denominator. And so then I'm going to say 8,000, 1, 2, 3, divided by that number. And I get 1. So I have a height of 1. So H is equal to 1 cm. Okay, now what do you think about having a base that is 50 meters, 50 centimeters in radius? So that's 100 with only 1 inch wide, with 1 centimeter high, and that's not practical, right? So G was I don't have time to write it here, but G is that's not practical to have a waste can with 1 centimeter high. All right, so this is the end of this problem. This is a good calculus problem. Today in class, we went over the last year's paper 2 question. There was a calculus word problem on there. You guys need to know how to do a calculus word problem. All right, if you need help, come in for tutoring tomorrow morning.